Hello children, in this lesson we are going to learn how to do factorization of algebraic expressions using identity 4. So what is identity 4? X plus a into x plus b is equal to x square plus x into a plus b plus ab. So this is what we have learned in our algebraic expression chapter, right? And how can we use it for factorization? Given an algebraic expression of this form, all we have done is just written this thing first on the left hand side. So if we are given an algebraic expression of this form, we can write it as product of x plus a into x plus b, right? And when do we use this identity 4 and not identity 1, because that also looks very similar? When we don't find perfect squares on the extreme. So if your numbers are 6 or 8 or 11, they are not squares. If there is 9 or 16 or 25, we can use identity 1. But if it is 6, 8, 11, that kind of numbers, then we can't use identity 1, and we try to find out, can we use identity 4. Let's take an example. P square plus 5p plus 6. So p square seems to be, we can use identity 1 or 2 or 3 or 4. Because there is a plus on both the sides, seems like identity 2 and 3 are not possible because it has negative. So identity 1 or identity 4 can be used. But 6, is it a perfect square of any number? No. So here, these are the places where we can use identity 4. So we write p square as p square, 5p as p into 5, and 6 as 6, right? And if you look at identity 4, it says x square plus x. So here p is same as x. So p square plus p into 5. So this is x. So can we write 5 as in some form of a plus b and 6 as a into b? So we have to think coming up of 5 as a sum of two numbers and 6 as a product of two numbers and the same two numbers. So if it is a plus b, if it select here 3 and 2, then we have to use the same 3 and 2 here also. So let's try to find out. So p square plus 5p plus 6 was given, which we wrote it like this. And now let's try to find out a and b in such a way that a plus b is 5 and a into b is 6. So that we can use identity 4. Because identity 4 says x square plus x into a plus b plus a into b. So can 5 be a plus b and 6 be a into b? How do we do it? So what should be the value of a and b? We can guess, very simple. Just start from the product number. We want 6. 6 can be a product of 1 into 6 or 2 into 3. So let's try with a as 1 and b as 6. So a into b will be 1 into 6. That's what we want to get, 6. Looks good. But what is a plus b if a is 1 and b is 6? Will become 1 plus 6, which is 7. But we need 5, right? So this means a as 1 and b as 6 is not correct value. If you take 6 and 1 also, you are going to get the same thing. 6 into 1 is 6, which is correct. That's what we expect. But 6 plus 1 will be 7. Whereas we want 5. So 1 or 6 or 1 are not the correct values of a and b. What are the other factors of 6? 2 and 3, right? Let's try that. If a is 2 and b is 3, then a into b is 2 into 3, that is 6, and a plus b will be 2 plus 3. A is 2 and b is 3, which is 5, and that is what we want. So we can write 5 as 2 plus 3 and 6 as 2 into 3, where a is 2 and b is 3, right? So then we can very easily use identity 4. So p square plus 5p plus 6 became p square plus p into 5 plus 6. And we can write 5 as 2 plus 3. We write it in bracket, and 6 as 2 into 3. And now it is looking like identity 4 can be applied, where x is p, a is 2 and b is 3. So we can write it as x plus a, that is p plus 2, into x plus b, that is p plus 3. Right? This was x, p was x, a was b, and a was 2 and b was 3. So we can write it as x plus a, that is p plus 2, and x plus b, that is p plus 3. So this expression of 3 terms is now written as p plus 2 into p plus 3, product of 2 factors. P plus 2 is one factor and p plus 3 is another factor. Right? So using identity 3, we simplified it. The challenge here mainly is to find out how do we write these numbers such that it meets a plus b here and a into b here.